Most people hit a specific number in a division problem and their brains simply halt. We've been taught this mental wall is a biological limit, that some people are born with a math brain and others simply aren't. In reality, that limit is a byproduct of the way we're taught to think. Standard education models prioritize slow, linear compliance over raw processing speed. Trying to process large numbers sequentially, digit by digit, is like trying to run modern software on a 30-year-old operating system. The failure isn't in the hardware, it's the protocol. Take a look at this, 1432 divided by 7. By the time we're done, you will solve it in under 4 seconds. Achieving that speed requires abandoning every procedural rule you learned in a classroom. The first step is to strip away the rigid academic terminology. We're getting rid of the word dividend. This is now the target. We are treating the number as a single structural entity designed to be collapsed. Standard left-to-right division forces your brain to hold multiple carryover values in your working memory, which quickly leads to a system crash. Approaching a number as a structure to be dismantled all at once, rather than a string of digits to be filed, allows for much higher cognitive throughput. How do you actually collapse a 4-digit target without the slow, linear steps? You use shadow multiplication. While division is an energy-intensive search for a value, multiplication is built on instant pattern recognition. The system operates using the 5 times tables as a baseline. Mastering just this single set of patterns automatically maps out half the division universe. With that 50% anchor in place, your brain can bridge the gap to the target through quick visual estimation leaps. This fluid pattern matching is several orders of magnitude faster than the rigid, procedural steps of long division. High-velocity math is less about calculating new answers and more about retrieving existing structural patterns. This is the point where 90% of students stop. The remainder. Most people see a remainder as math trash, a leftover that doesn't fit into the clean answer. In the Slicer's protocol, we reframe this as the power gap. If you have 17 cookies for 3 friends, everyone gets 5. But the calculation isn't over. Those 2 unallocated units are the most interesting part of the problem. They represent the distance between where you are and where the next whole number begins. Recognizing that unallocated gap allows you to accurately measure the precise remainder that most people simply ignore or round away. Let's look at 1432 divided by 7 again. Instead of dividing digit by digit, we identify the largest recognizable chunks of the target, 1432. 1400 divided by 7 is 200. 32 divided by 7 is 4, with a power gap of 4. The answer is 204, remainder 4. You just solved a 4-digit division problem by manipulating patterns without performing any traditional arithmetic. Numerical mastery isn't about following rules more closely than everyone else. It's learning to decompose a complex problem into simple patterns